Okay, everybody, here is the review to Chapter 2. First question says to take this polynomial and put it in standard form. So we know we have to put the biggest exponent, 4x cubed, then the next exponent. So you go all the way down in order from the largest exponent down. So 4x cubed plus 10x squared plus 3x minus 5. The degree is the biggest exponent. So the degree is degree 3, and that tells me that there are 4 roots. That's why knowing the degree is important. The leading coefficient after you rewrite it is the number in the front. After you put it in order, the 4 is leading the charge, okay? So it has 3 roots because it's degree 3. P of 2i, easiest way to do it is I'm plugging 2i into each of these, is just to plug it into the calculator. So plug it in. I went 2i in for x, 2i in for x, 2i in for x, and I just let the calculator do it. I just plugged it in with the calculator. So there's an I button on here, so I can just go 4 parentheses 2i cubed plus, see the I is in the calculator, plus 10 times my 2i squared plus 3 times 2i, you got the idea, minus 5, and I get an answer, okay? And then there it is in terms of I. It's so much easier, just let the calculator do the work, okay? Number 2, I'm going to divide this polynomial, but I got to make sure that I include the 0, x squared, because 0 is not in it. So I've got 3x cubed plus 0x squared plus 4x minus 1. Now I use synthetic division, so 3, 0, 4, negative 1. I have my add line. Take the opposite of negative 2, right? Opposite of 2 is negative 2. Bring down the first term, multiply, add, multiply, add, multiply, add. So that these numbers are the coefficients. My x's were invisible. I bring them back. 3x squared minus 6x plus 16. Remainder negative 33. So negative 3 over x plus 2. Now, since we got a remainder other than 0, it is not a factor, okay? If it goes in evenly, you'd have a remainder of 0, right? But it did not. Okay, number 3, I know that these are my zeros. I have x squared is x times x. So I have x at 0. I've got another 0 at 0 because of the x squared, 3 and negative 1. So I've got zeros here, a double root here, and a root here. I know from end behavior, since it's negative, it starts down at negative infinity, goes through. Since double root, goes through it again, and back through. Okay, that's the picture. Okay, number 4, I'm going to need to set it equal to 0 in factors. I brought over the 8. X squared, multiples of 8 are negative 4 and 2. If I solve my mini equations, plus 4 squared, I get plus or minus 2. Those are my first 2 roots. Minus 2 minus 2. Take the square root. Now I've got a square root of a negative number. So plus or minus square root of 2 and negative 1. Square root of negative 1 is I, so it's just plus or minus, plus or minus the square root of 2i. Okay. 5. Let's see. Brought them over the 6x, brought over the 3, and I grouped them, the first 2 together. And after I brought those over, I grouped the second 2. I took out a 2x squared out of the first term, 5x minus 3. There's nothing to take out, so we take out a 1 because we needed something here. And then we'd have a 5x minus 3. They both have a 5x minus 3 in common. I take that out. I'm left with a 2x squared plus 1. I have my mini equations, 5x minus 3, 2x squared plus 1. I solve plus 3 divided by 5. I solve minus 1 divided by 2 square root. Now I've got a negative, so I've got to be careful. So I've got plus or minus square root of 1/2 I because of the negative, okay? 6, what we have, I think the easiest way to do it is to show kind of other type of problem. So for example, just way off, kind of not off track, but a little side work. You know if you divided 5 into some number, and the answer is 4, with the remainder of 3, this is what we're looking for, is this number. Well, you can go 5 times 4 plus 3, and that's all we're going to do is we're going to take 2x plus 1 times my x squared plus 3x minus 4 and a remainder of 5. So I'm just multiplying it. So I FOILed it. I got 2x cubed plus 6x squared minus 8x, 1x squared plus 3x minus 4, and it brought down to 5. Combined terms, 3x squared plus 7x minus 5x plus 1. And that's my original polynomial that we divided, okay? 7. My roots were 4, 2 plus the square root of 3i, and of course then there has to be another one, 2 minus the square root of 3i. I know that to get the 4 came from an x minus 4, but to get this, I know it came from some quadratic, so I used my formula, x squared minus the sum of the roots times x times the product of the roots. So, okay, if I want to do this formula, I took the two roots and I found the sum. 2 plus square root of 3i, 2 minus square root of 3i is 4. So the 4 has to go there. Then I wanted the product, so I multiplied them. 2 plus square root of 3i, 2 minus square root of 3i. I went this times this is 4, this times this times this, and this times this. So I got a 4 minus 2 square root of 3 plus 2 square root of 3 minus the square root of 9i squared. Those two cancel. Square root of 9 is 3. I squared is negative 1. I get 4 plus 3 is 7, so that goes there. So here's my answer. Okay. 10. I've got to make 3 fences. I've got to put fencing here, 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 and here. So I got 4 pieces of fencing. So out of my perimeter of 100, I take away my 4 pieces of fencing. My length is going to have to be 100 minus 4x. Okay, no problem. If I know area is length times width, I've got x times 100 minus 4x. I distribute it to make it a little bit easier, so I got a negative 4x squared plus 100x. I know I'm looking for the maximum, which is like the vertex, so I use the negative b over 2a. So negative 100 over 2 times my negative 4, 100 over 8, which is 12.5. So I need to make each of these fences 12.5 meters. Now the length is 100 times my 12.5, which turns out to be 50. So my dimensions are going to be 12.5 by 50. And that area, when I multiply it out, that area is 625, okay? Now the domain, the smallest these pieces could be is up to 0. And the biggest these pieces could be is 25, because 25, 25, 25, 25 would take up all of my perimeter, so the biggest these could be is up to 25, okay? All right. That's all I have. Oh, the extra. That's right. So the extra real quickly. So you take a piece of paper, right? You're going to roll it up into a cylinder, okay? The perimeter is 200, but the shape can be anything. We can just modify it, but the perimeter has to be 100. So what I'm going to do is make x and x, so it's a rectangle. So out of the 200, if I take away the two x's, divided by 2, so I can put half of it here and half of it here. So 100 minus x has to go here and here. So I roll it up, and here's my cylinder. The circumference is x, and the height is 100 minus x. Okay, well, what's the volume of a cylinder? It is pi r squared h. That's an h, a sloppy looking h. So I know the height, that's pretty easy. The height's 100 minus x. I don't know the radius, I know the circumference. Okay, well, what is, to find the radius? We know in geometry, circumference is 2 pi r. Well, I know what the circumference is in this figure, it's x. So if I want to solve for the radius in terms of x, divide by 2 pi. So my radius in terms of x is x over 2 pi. So I put that there. So okay, so here's my volume. Pi radius squared times my length. I just simplified a little bit to make it easier with pi. Make that x squared and 4 pi squared. Squared it. My pi's will cancel. So I'm just left with 1 pi. And then I graphed it. And when I put it on my calculator and graphed it, I'll show you what I did. So I put my x squared times 100, put my x squared times 100 minus x divided by 4 pi. I had to use parentheses for 4 pi, so I divided by the whole thing. Now the window, it took me a while to find the window, but the window, it's a big thing. So it went all the way to 100 and all the way up to 20,000. It's a big cylinder, I guess. I didn't know it was this big, but then I graphed it, found my maximum. I did my calculate. Went to my maximum. I did left bound, right? Oop, this is left bound, which is over here. Left bound. Get the cursor locked in. Right bound, move it over. Cursor's blinking, I lock it in. It says guess. You don't have to guess. Hit enter. And there it is. So 6.66 and 11,789. Well, that has to be the x, which is the circumference, or this side, 66.6. And that's the volume, okay? The volume is 11,789.25. The length is 100 minus 66.6. What's that? A 33.3, I think. And that is how you would build your cylinder to get the largest volume. Okay, and that's all I have. Take good notes, and I'll see you tomorrow.